Hello and welcome back to Jason Live. We're here once again with our STEM career series where we learn about careers in science, technology, engineering, and math from role models working in those fields. Today's role model is Jendai Robinson. Jendai is pursuing her PhD in chemistry at the University of Cincinnati. She also spends a lot of time in the labs at NASA Ames Research Center, where she's a NASA Jenkins Fellow. She studies ways to use nanotechnology to create biosensors that can detect toxins better than anything available today. We're going to learn about all that and more when we connect with Jendai in just a moment. But before we do, just want to remind everybody that today's event is live and interactive. We're going to be taking your questions and asking you to participate in our polls. To do both of those, just use the box right below this video, and we're going to try to get as many of you involved in today's program as we can. Right now, I'd like to get Jendai involved. Welcome, Jendai. Thanks for joining us today.
Yeah, thank you for having me.
All right, there's your audio. All right, we're going to jump right into the questions. We've had a lot of questions already come in through the Jason website, and our first one is coming in right now from Brooke. Okay. And Brooke asks, great question to get us started, what exactly is a chemist and what do they do?
So a chemist studies chemical activities, and what they do ranges. So there's different fields of chemistry. We have inorganic chemistry that work with non-carbon materials, and then we have organic chemistry that works with carbon materials, and then we have physical chemistry, and we have analytical chemistry. So there's different ranges of chemistry, and what they do varies. They may develop biosensors, which is what I do. They may develop different things such as to help in releasing of fragrances and just all sorts of different things.
We've got a couple related questions here. Kathleen asks, what's your favorite chemical? Great question to ask a chemist. And Caitlin wants to know, what are the most common chemicals that you use in your job?
What is my favorite chemical? That is a good question. I guess my favorite chemical is water. Yes, water is very important, and and the most used chemicals that I do or work with are polymers. So like little plastics, and I work with acetone, and everybody that's into nail polishes should know what acetone is. It removes your nail polish, and I work with that, ethanol, and water. I work with a range of different chemicals, salt with sodium chloride. It's basically table salt. I work with all different kinds of chemicals.
Our audience out there is very interested in the work that you do with NASA. Ben asks, what do you do while you work at NASA? And Dylan wants to know, how are you associated with NASA? What does NASA and chemistry have to do with one another?
Okay, so one of the misconceptions about NASA are that NASA is all about space and astronauts and space shuttles and things like that. But what really drives NASA isn't just the engineering aspects of it or the space aspects of it. It's actually very interdisciplinary. So you have engineers, you have chemists, you have lawyers, you have all types of different people working at NASA. And what I do at NASA is I work at the NASA Ames Research Center as a Jenkins Fellow. So that's how I'm associated with NASA. I'm a NASA Fellow, and I've also been a NASA Ambassador, and I've also been a NASA intern. So I've had internships there. So that's how I'm affiliated with them. And what I do in the Center for Nanotechnology is build devices that are on the nanoscale. And the nanoscale, if you to conceptualize it, if you can think of $1 billion, and we know how big $1 billion is, in exponential notation, it's 10 to the 9. Now I work on the opposite side, so I work on 10 to the -9. So that's I build those devices to detect biological substances. And one of those things that I do is work with nanoporous alumina, gold nanorods, and carbon nanofibers. And what we can see here are gold nanorods. And these nanorods are approximately 13 nanometers and 60 nanometers. So that's how small these devices are. And that's what I do there.
Cool. We have another neat image here. You mentioned carbon nanofibers, and we're seeing that is the darker tube in this picture. And what is that laying across?
That's a human hair. So you can see that your human hair is huge compared to carbon nanofiber. A carbon nanofiber is smaller than one strand of your hair. And what we can do, this is another image of carbon nanofibers, and what we can do is pattern them on a surface. And then we can grow individual or grow a collective bunch of them on specific patches. And then from there, we can use electrochemistry, which is just electricity and chemistry, and detect different chemicals or different molecules such as glucose or glucose for diabetes, which is very important.
Very cool. We've got another NASA-related question here. Jalise wants to know, are you currently working with NASA on a project, or are you currently working on a chemistry project? And are those actually the same thing?
Yeah, so yes, I'm working on a NASA project, and yes, it is a chemistry project. It's the same thing basically. And the NASA project that I'm working on is building devices that haven't been built before. So, and the reason why we're building these devices is because there is a need for them. So one of the motivations for my project is to develop a fast, cost-effective, and sensitive device that can be used in areas where technologies aren't necessarily afforded because of how expensive they can be. So if we can scale them down and make them selective and sensitive, there isn't so much need for these big bulky materials. And NASA is interested in this because I don't know if anybody knows, but there's a space station in space that's orbiting around us as we speak right now, and it's called the International Space Station. So another application of my project is to use these devices on the International Space Station in space. And it costs a lot of money to send instruments to space. So if we can drive down the weight of the product, then it would be even more efficient. And the scientists on the International Space Station can use these devices and help us down on Earth.
We've got more questions coming in about nanorods. Bunch of students in Mrs. Bound's class want to know, how are nanorods made, and how do you use the gold nanorods specifically?
Okay, so nanorods, the way that we use nanorods is through a lithography technique. And what you're doing is basically putting polymers on the surface of a glass, and from there you can pattern the surface and then put gold into holes. So we put polymer down, and then we use another polymer, polystyrene, and everybody might know polystyrene from styrofoam. So you know, when you're buying your TVs or your Xbox or your Wii's, and they come in styrofoam, if you just add something that's in your cabinet right now, acetone or nail polish remover, you'll get polystyrene. Now our polystyrene are spherical, so they're little spheres, so they're 400 nanometers. And from there you put the polystyrene spheres on top of the surface, and then we do a little bit a technique called etching, and what that does is just like essentially burn a hole into those polymers, and then we put gold into those holes, and then after the gold is into those holes, we take the polymer off, and then that will generate the nanorods that you see in the pictures there.
We've got some questions coming in, a group of questions here about being a chemist and what you love about this. So Caitlin asks, what is the best part about being a chemist? Students in Mrs. Bound's class ask, what's your favorite part of your job? And Connor, actually, that's getting into our experimentation line of questioning. We'll come back around on Connor's question, but what is your favorite part about being a chemist?
So my favorite part about being a chemist is doing things that no one has ever done before and becoming a pioneer in that field. You know, when you discover something and it's like, yes, like I did this. That's the best part about being a chemist, is working with something that can then be used for other people. That's like when you see it being marketed, you're like, hey, I did that. That's what I did and on this day at this time, you know? And that's one of the most thrilling experiences, or, you know, what makes chemistry worthwhile, and that's my favorite part of it.
I mentioned that we have questions about experimentation. Connor wants to know, how do you feel about experimenting, and do you succeed in your experiments? And Danny wants to know, what do you have to do to make your experiments work? What's the process like for doing your work?
Okay, experimenting. Now, you know, just like anything, you have your good days and you have your bad days. And experimenting, one day what you did might work, but then the next day it might not work. So it can be a toss-up. You know, you could be very happy some days, and then some days you can be very sad and frustrated because what was just working just stopped working. But a way to I guess fix that, and with a positive attitude and saying, and then problem solving. And one way that you get things to work is reading. And now a lot of science is done by reading. So it's that you can go back to I guess the library and research this and look in books and say, well, somebody did something like this before and it worked. So what did they do? And then you can read and say, oh, well, they didn't set up their experiment this way. They set it up this way. So you're basically problem solving and being proactive in the process. So that's how you get things to work.
Danger is always a very a favorite topic of our audience out there. And we always get lots of questions related to danger, related to careers, and certainly with a chemist, this is no exception. So I'm going to toss a bunch of questions out there related to danger in your work. Gavin wants to know, what chemicals do you work with that are dangerous? Hannah asks, can being a chemist be dangerous? And Ms. DeMayo's second grade class wants to know, what kinds of chemicals have you worked with that are dangerous? And I'm going to post a few more questions that folks have asked along these lines, because they're all very interested in this kind of stuff. So is it dangerous what you do?
Of course. Yes. Yeah, you're working with chemicals at sometimes high concentrations, and it can be dangerous. If we're working with hydrochloric acid. Hydrochloric acid can burn your hands. You know, we're working with salt. Salt can be very drying and irritating to your skin. Acetone can irritate your skin. I mean, there's so many different things in a chemistry lab that can be dangerous. And I mean, you just have to be, again, proactive, and there are safety protocols put in place to ensure that you don't harm yourself. And there's a lot of, they call it PPE, personal protective equipment. And what that we use in the lab are lab coats so that we don't get anything on our clothes. We can use safety goggles to protect our eyes, because if we have to pour things, we don't want to pour things over our eye level just in case they splash into your face. You're wearing gloves so that you don't get anything on your hands. And then you refer to what they call material safety data sheets, or MSDSs. And these are people that are dedicated to people, or every chemical that has been made has a MSDS sheet. And what you're doing, if you're working with a chemical that you're unfamiliar with, you refer to this document, and it's public knowledge. Anybody and everybody can access them, and they give you all of the hazards that are associated with that particular chemical. And then they say, or they tell you what to do in case something had spilled on you and things like that. And one of the most dangerous chemicals that I have worked with has been sodium azide. And sodium azide, it has been one of the most dangerous chemicals that I've worked with because it is an explosive. So if you're not careful, if you perturb the surface or you hit the surface too hard, or even very sensitively, even lightly tap it, it can explode. So, I mean, that's again why there's safety protocols put in place to ensure that you don't harm yourself, and you're using, explosive glass, and making sure you have your eye goggles on and your lab coat and things like that. So even though it's dangerous, it could be relatively safe.
That leads us into our next couple of questions here. Aaron wants to know, how good are you at what you do? And Rachel asks, what personality traits do you need to do your job?
Okay, so Aaron, that question, how good at what you do, that can change on a daily basis. Just like I said, like you could say, "Hey, I'm good at this because I got it to work," and then tomorrow it's like, "Darn, I stink at this because it's not working anymore." And so, I mean, I've been doing it for a while now, so I think I'm pretty good at what I do. And it being a graduate student now, and this is what I'm going to be working on. I'm going to be the only one working on this. So even though sometimes I personally may not think I'm good at it, I'm becoming an expert in this field because nobody has done this before. So I'm going to be an expert. So I'm going to be really, really good at it. And I'm sorry, what was the other question?
What personality traits do you need to do your job?
Okay, what personality traits? Like I said, you have to be hardworking and persistent, and optimistic. Because some things may not work, and you don't want to have a pessimistic attitude and say, "Oh well, it's not working today. Oh well, like I don't know, forget it." It's like it's not working today, and I wonder why it's not working. So, being inquisitive and driven and motivated are some personality traits that I think are essential for pursuing a career in chemistry.
Well, this
especially
brings up a
chemical
great question from Sophia. She wants to know, have you ever done an experiment that went completely wrong? If so, what happened and why? And you see, there's a question from Shannon there. We're going to come back to that just after this.
Okay, an experiment that went completely wrong. So an experiment that went completely wrong. Let's see.
Stumped you, huh?
That's a difficult question.
What about kind of a totally unexpected result from one of your experiments?
Okay, so I have an idea. I didn't know if I wanted to say it, but when I was a freshman in chemistry in my undergraduate career, I learned the hard way when it comes to the saying, you don't want to add water to acid, or acid to water, because what happened was I had acid and I was getting rid of it, and I turned water on. And what happened was the reaction was very exothermic, so it put off heat. So it was sulfuric acid at the time, so I added water to sulfuric acid, and it essentially a big cloud of smoke just came into the air, and I was like, oh, okay, yeah, that's not what you're supposed to do.
And
But
this is
luckily, I
why,
was protected. I had goggles on, and I had gloves on, and I had a lab coat. So, you know, nothing was wrong. Plus, it was just smoke. It wasn't like it didn't spit at my face, even though some can do that. But that.
all right, our connection is getting a little choppy, but we're going to keep on rolling with Jendai here. Our next question is going back to this question from Shannon. What's the coolest thing you have ever done that's related to chemistry?
Okay, one of the coolest things that I've done has been working on the project that I'm working on now. And it's cool because of the applications that they have. Now, one thing that the lab that I work at NASA has done is work with these carbon nanofibers. And what happens with these carbon nanofibers is that they have electrical properties. So one experiment that was done was called deep brain stimulation. So what this patient was, they were a well-renowned, a world-renowned violinist, and he had played in multiple recitals, and developed a tremor, and so his hand is shaking and shaking and shaking and shaking and shaking, and he's not able to play the violin anymore. So they had, or my boss, Jessica Keeney, Dr. Jessica Keeney, has a collaboration with the Mayo Clinic, and they were able to implant these carbon electrodes into the patient's brain, and put in some electrical pulses that stabilized his tremor. And he was awake during all of this, and he was playing the violin. So it was like, shaky, 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 and not playing very well. And then once the electrical stimulation was put in, he was able to play the violin like he never had a tremor before. And these carbon nanofibers has been some of the coolest things that I've worked on because of what they can be used for.
Well, I think you just answered Katie's question here. Have you ever created a chemical to put in medicine to cure a sickness? That seems pretty related. And now that you mentioned that violin story, I have seen pictures of that. That's really cool that you were involved in it. We've got a couple questions next about the tools that you use to do your job. Sophia wants to know, what does an oxygen plasma etcher do to help you when you're working? And Will wants to know, what is a UI vis spectrometer and what does it do? I don't even know if I'm pronouncing that right.
So, oxygen plasma etcher uses an oxygen plasma, and it basically gets rid of excess polymer on our substrates. So, like I was saying, we use these polymers to pattern the surfaces of our nanofibers. And what the plasma does is essentially burn a hole through the polymer. And it's pronounced a UV vis spectrometer. So UV and then vis spectrometer is a spectroscopic technique that we're able to measure the different colors in solutions. So from there, we're able to get concentration information and things like that, information like that.
Very cool. So we have learned a lot about the kind of work that you do today, the kind of projects that you're involved in, and right now we're going to jump back in time and learn about your career path. What got you to where you are today? And we've got questions that are going to take us in that direction now. Here's a group of 3 from Grace, Megan, and CJ. Grace wants to know, what first sparked your interest in chemistry? Megan wants to know, why did you start a career in science? And CJ asks, what made you start doing chemistry and why did you do it? So, what do you have to say about that as you get settled in here again?
Okay. I'm sorry. My computer was about to die, so I needed to plug in into the outlet.
All
Okay.
right, so we are back and we're talking about
What sparked my
these
interest?
questions. Did you happen to catch those
Yeah.
questions as
What
you were getting plugged in?
Yes. Yes, I did.
Great.
So what sparked my interest in chemistry was actually my father. So my father isn't necessarily a chemist. He actually is a auto technician. And so he works on cars. Now, that may seem unrelated, but if you actually think about it, when he used to take me to his job when I was about 7 years old, you can't have a little child running around a machine shop or a car shop. So what he would do is he would give me little projects, and one of these projects was to test the function of a radio. So he would have me pressing all the buttons to make sure that it was working, the radio was working, and if it wasn't working, I would let him know, and then he would change certain things in the circuit board that the radio would work. Another project that I remember very vividly was he took me to his job, and we were working on building a circuit, which I didn't know at the time. So he had me taking the car headlights or little bulbs that go in the car headlights. He gave me some wire and a portable battery pack, and he said, connect this to this one and connect this to that, and put these little wires towards this and see if the light turns on. If the light turns on, put it back in the drawer. If the light doesn't turn on, it's broken, throw it away. And I was making electrical circuits and didn't know about it. So that was like one of the main contributors that sparked my interest in chemistry and what kind of guided my path into science. My dad has been an extreme role model to me, as well as several other people. But fundamentally, it's been my dad, and yeah, that's a really big thing for me. Yeah, those experiences.
Our next question is from Yasmin. She wants to know, what were you like when you were her age? She's in 6th grade.
Oh, in sixth grade. In sixth grade, I was all over the place. Um, I'm still pretty much the same. I'm just a little bit more mature. But I ran around. I played in parks and hung out with my friends and you know rode bikes and you know all kinds of different things. Like I'm pretty much the same way, silly, energetic. I'm pretty much the same way.
Okay. Hannah wants to know, what was your favorite thing to do in school? And Elizabeth wants to know the opposite. What were some of the things you hated about school?
So my favorite thing about school. My favorite thing about school was history class. I loved history class. And one thing that I hated, and one thing that I hated it was because that it was so hard for me was math. And like I couldn't understand it conceptually. Like I have to add these numbers in my head. How do I do this? Like what do you mean? I like, because I was so visual. I was a visual learner, and I was like, wait, I have to think about this and put it in my head. And it's like, this is hard. Like, I hate it. Like, I don't want to do math. This is stupid. And another thing, to go back to like the story that I told before, like my dad helped me get over that because he would take pennies and he would say, how many pennies is this? And if you add these many pennies, how much do you have now? So it was like, oh, okay, I can understand that. And then I was able to start enjoying it more and more and more. Because the reason why I hated it wasn't because I hated it, it was because I didn't understand it. So, yeah.
This leads us into our next few questions here. Allison and Annika pretty much have the same question. What was the biggest challenge you faced when becoming a chemist? And Alessandra asks, how did you face those challenges? How did you overcome them?
Yeah. So when becoming a chemist, one of the biggest challenges you face, um, is how difficult some of the classes might be. Like I was saying, math, because in chemistry, we use a lot of math. And like I said, I had issues conceptualizing it. And, it started to, we may think of math as just algebra, but then it can get even more complicated than algebra and be pre-algebra and then be pre-calculus and then calculus. And you have to derive certain equations and you have to understand where they came from. And then it's like some of these classes are just so difficult, even some chemistry classes. And one thing that people struggle with, or what some people, or what I have personally struggled with, has been inorganic chemistry. And a particular field in inorganic chemistry that I have struggled with was rotations of a molecule inside of your head, because we can see in 3D and we see that the chair is 3D and we can move the chair around physically, but can we move the chair around physically in our or mentally in our minds? And it's like assigning different point groups and things like that, and understanding like how they are, like that can be very difficult in understanding. And one way that you can get over that is going to see your professor or your teacher and saying, can you please explain this to me because I don't understand it? Or seeking out additional resources. And modern age, I can just go on YouTube and Google and search this and have a personal tutor say, oh, well, this is how you turned it in your head, or this is how you can think of it, and using different modeling kits and seeing, oh, okay, and then transferring that and without the kit anymore and without the model, and saying, oh, okay, yeah, I know what that, I can manipulate this in my head now. So
That's
that's
really
one
good
way.
advice, and it sounds like you're capable of doing anything as long as you put enough hard work into it. Is what I'm
Yes,
hearing you say.
definitely.
Yeah.
That's one thing about chemistry, is that you have to put, and science in general, you have to put in a lot of work and understand that it's not going to be easy, but not giving up. That's very important. It's not giving up, not being, not just because you get a no, or just because you don't understand it the first time. Just have a little bit more faith in yourself and be patient with yourself and say, I am capable of learning this and I will learn this, and this is how I'm going to learn it.
We've got a few questions here about role models. You're a role model with us today, but you had role models getting to this point in your career. Diedrich, wants to know, who was your chemist role model? We have a question about Dr. Victor Vilches, who you mentioned as your role model in your STEM role model profile answers on the website. And Jaden wants to know, why was he such a great role model to you? And what types of things did he do to be a role model?
Yes. So, like you said, who my chemist role model was, and my chemist role model was Dr. Victor Vilches, and he's a professor at my undergrad institution, Virginia State University. And he's my role model because he does many things that help me in understanding chemistry, and many things in understanding what to do to get ahead, such as networking and preparing a resume and getting jobs and internships. And he would take the time out of his during his office hours to explain to me things that I didn't understand, such as when I was talking about the manipulations of molecules in your mind for inorganic chemistry. He was like, well, here's a modeling kit, or you can think of it this way. And just assisting me and being supportive. That was one thing that Dr. V did for me, is he was very supportive, and didn't say, oh, you can't do that, you're not smart enough. He was like, no, you're smart enough, and this is how I thought about it, you can think about it this way. And he wasn't just a chemist, like he was able to help me in math, and he was able to help me in physics, and even some other things. So I mean, he was just so well-rounded, you know, and being able to talk to people for me and saying and saying, you know, this is a really good opportunity, and pushing me to do things that I wouldn't necessarily do. So, you know, such as traveling and like go to Washington, you know, you can probably use marine biology and chemistry and, you know, things that I wouldn't necessarily think of, that he has thought ahead and he said, yeah, you should do this. And it's like, okay, well, I mean, he thinks he believes in me, so I mean, I believe in me too. And that's why Dr. V is so important to me. And I still speak to him to this day, you know, and his wife and his child, you know. So yeah, Dr. V is like a father figure to me. Like I can even address him as, hi dad, you know. He's just that close.
Well, that's great. I hope he's watching today and hearing all this great stuff that you're saying about him. We're going to take one more question here in the career path segment. It's from Olive, and she wants to know, how long have you dreamed about being a chemist? When did this dream start?
How long have I dreamed about being a chemist? So I actually didn't want to be a chemist when I first started out. I wanted to be a doctor, but I wanted to be a medical doctor. And going back to Dr. V and him suggesting that I take an internship at Virginia Commonwealth University, that changed my mind. It was like I wanted to be a doctor, I wanted to be a doctor, I wanted to be a doctor. And I was researching what was necessary to become a doctor. And it's like you have to go into a science field, you know, biology or chemistry. And, you know, chemistry is more useful because of all the mathematics that's involved. And then I can have a concentration in biochemistry so that I can understand the biology that's necessarily for medical doctors and entrance into medical school. And then when Dr. V suggested going to VCU or Virginia Commonwealth University, I was like, okay, why not? And from there, I was like, well, I don't want to go to medical school anymore. I want to go to graduate school. So from there on, I solely like wanted to be a chemist instead of like a medical doctor. And even though I'm not a medical doctor, I'm still working towards a doctorate degree. So I will still be a doctor. I just won't be a medical doctor. And even though I'm not working with uh, surgeons and patients or patients directly, I'm working behind the scenes and helping the medical doctors.
There's lots of different ways to be involved in important work.
Yes,
So
yes.
we're going to move on now, and we've asked you a lot of questions already, and we have some more to ask, but we're going to give you a chance to ask our audience some questions through our polls. And Jendai came up with these questions herself, and we're going to take the first one now. So take a peek and vote. What countries has Jendai visited or lived in as part of her job as a scientist? Has she lived in or visited Jamaica, Colombia, Mexico, or all three of those places? Jendai, we really haven't talked about travel yet. We have a few questions that are travel related that we haven't gotten to, and maybe we will, but maybe we'll answer it right here in the polls. So we've got some answers coming in already from our audience, and it's kind of mixed. 20% think Jamaica, 33% Mexico. There's still some answers coming in changing, but most of our audience right now think all of the above. That's up to 63% now think it's all of the above. So why don't we actually, it's up to 70%. We're going to close our poll response window here, and why don't you tell us what the correct answer is?
The correct answer is all of the above. Good job, everybody. Yes, I've been to all three. I've been to Jamaica, I've been to Colombia, and I've been to Mexico. And Mexico was one of the most recent countries that I visited.
That's great. What kind of stuff did you do in those places?
So in Jamaica, it was more for pleasure. And in Colombia and in Mexico, I went to some of the pyramids and the Aztec ruins that are there. And in Colombia, I went and learned about coffee and the process that coffee goes through. And I visited some mountains and some other things too, learning about the city and the culture. And that gaining international exposure and experience is important, and identifying with different cultures is important, especially in chemistry. And one big thing about Colombia is that helps in research and medicine is the Amazon rainforest. And I actually plan on going back there to learn more about the drugs and things that we use now for medicine in the Amazon.
Sounds like there were some amazing experiences and more to come. We're
Yes.
going to jump into our next poll question here. And we've already got people answering this. What equipment does Jendai not use as part of her research? Does she not use A, a Fourier transform infrared spectroscopy, B, atomic force microscopy, C, scanning electron microscopy, or D, she uses all of those in her research? So because folks got a little bit of a head start on this, they think 63% of them actually think that you use all of these tools. I don't think we've talked about all of these today, but 22% think it's A, the Fourier transform infrared spectroscopy, and we've got a few people that are guessing B and C. But right now, 71% think that you use all of these tools. What's the right answer, Jendai?
So the correct answer is A. I do not use an FTIR. I do use an SEM, a scanning electron microscope, and I use an AFM, an atomic force microscope, but I do not use an FTIR.
And there you have it. We're going to jump right into our last poll question. If Jendai did not study chemistry, which of the following subjects would she have pursued? A, history, B, art, C, physics, or D, philosophy? Now, I think you might have given a little bit of a hint to this in your poll question. I'm sorry, in your questionnaire that we have online, but I don't think we've talked about this specifically. You've talked a little bit about a couple of these earlier, and folks are answering right now. History and physics are tied with 43%. Nobody is guessing art, and 13% think philosophy. We're going to give them a few more seconds to weigh in here. History has taken the lead, followed by physics, and then philosophy. History seems to be pulling ahead. Jendai, what is the correct answer?
The correct answer is history. Yes, good job, good job. Yes, the correct answer is history. I have a huge interest in history, and that's another motivation of going to all these different countries is to learn the history behind them, and going to the pyramids and learning the history behind how they were made and why they were made. So yeah, history takes, yeah, that's what it is.
There you go. We have just a few minutes left in today's program because we've been answering so many questions. So I'm going to kind of try to rapid fire and get a few more in here before we have to wrap up. So our next question is going to be from, let's pull it up here. I'm going to get clear past the polls. Nisa Chu wants to know, if you had a different job, what would it be and why? Would you be a historian?
If I had a different job, I think I would be a historian, but I would want to be a traveling historian, because I think what's more influential and what will um, reinforce the knowledge and the retention of the information is actually going there and experiencing what other people have experienced. You know, going to the museums and seeing things, firsthand, and understanding the language, and taking time to learn the language is important also. So yeah, I would definitely be a traveling historian and learning all these different languages and the history behind the country and how they were founded.
We've got a great question here from Rebecca. She wants to know what's around your neck.
Oh, so right now I'm streaming from the Novashe conference. So what's around my neck is my name tag. So yeah, I'm here representing my graduate school, and I presented a poster. Just like I said, a big thing for science is communicating your science. That's very important, because if nobody knows about what you're doing, it's like, why are you doing it? So that's one thing that I'm doing here now, in actually New Orleans, and I go to graduate school in Cincinnati. So, I guess one of the misconceptions about being a scientist is that you work in a lab all the time, and that is far from the truth. You go all kinds of different places and talk about your research. So that's what I'm doing here in Louisiana right now.
Our next question is from Nikki. What are some things that you make that haven't been made before?
So some things that I make that haven't been made before. So I guess, let's see. The actual device that I make hasn't been made before. Now, some of the other things that go into the device have been made, but they haven't been designed and operated the way that we're going to design and operate them at. So what I do now with these nanoscale biosensors, they haven't been made before. So that's something that, to answer your question, that's something that hasn't been made before that I make.
Dawson wants to know what has been your biggest project so far, and did you accomplish it?
So Dawson, one of the biggest projects that I've had is actually working on my doctoral degree. So right now I'm on my second year of my program, and this program typically lasts 4 to 5 years. So this is one of my biggest projects that I've worked on, because it's going to be one of the longest projects that I've ever worked on. And I haven't accomplished it yet, but I fully intend on accomplishing it. And I'm working every day towards finishing my research, or my research dissertation.
This might answer John's question as well. What's your goal as a chemist? You kind of talked about some of your near-term goals. What's the long-term goal?
So the long-term goal, I mean, since I'm still in school, so I guess one of those goals is actually finishing my degree, and another goal is actually probably working for NASA and developing and innovating more technologies that can be used for everybody and anybody.
We've got a question from Daha. Hopefully I'm pronouncing that right. Have you inspired other kids? How, where, and when have you done that?
I have inspired like other children and other, I guess, peers of mine, and ways that I inspire them are doing what I'm doing now and talking to you guys and letting you know that you're able to do things, and not to think that they're too hard and that you're not smart enough. And I tell them, if you need anything, please contact me, and I can give you different resources that you can go and search and find, so that you don't feel alone and discouraged. So yeah, like totally, and all the time.
And for our last question of the program comes from Nikki. What would you say to convince her generation to get into the world of chemistry?
So to convince you to get into the world of chemistry, if you're into working hard and not being discouraged, it can be very rewarding. It can be very rewarding intellectually and financially. So I can bribe you with money, but they pay for school. So some of the other majors, they may not pay you to go to school, and a lot of, I guess, some of the soft sciences and even social sciences, you have to pay to go to school, whereas, or go to college. That's what I mean by go to school, and go to graduate school even. And you can apply for certain grants and certain fellowships and certain internships that aren't afforded to, a philosophy major or an art major. Right now, for my undergrad institution, I was able to qualify for different scholarships and grants because I was a science major, and I was a hard science major. And even now in graduate school, I was able to obtain a fellowship that pays me like a stipend and pays my tuition and gives me the opportunity to work for NASA. So if you are into that types of thing, this would totally be something that would work for you. So yeah.
Well, that is all great advice, and it has been fascinating to hear you talk about your work and answer all of the questions that came in from our students today. Thank you once again. You've been quite an inspiration for all of us.
Thank you.
All
Thank
right.
you. Thank you. Thank you again for inviting me to talk to everybody.
It's been our pleasure. We're going to move on and talk about when our role model series returns in 2 weeks. We're going to connect with mechanical engineer Matt Brumbelow. You might recognize Matt. He's a host researcher in Jason's terminal velocity curriculum. He works at the Insurance Institute for Highway Safety, where they intentionally crash cars to find out how safe they are and figure out ways to make them even safer. To learn more about Matt, the work he does at IIHS, and how he got to where he is today, join our live event on Thursday, October 9th at 1:30 p.m. Eastern. Until then, for Jason Learning, my name is Patrick Shea. We'll see you next time on Jason Live.